Hello, my darlings. Okay, so what I want to look at now is the repeated integration by parts, where we found a u and a dv, and we used our rule, and then we found we had to do it again, and we had to do it again, and we had to do it again. We saw several of those in class, and we wondered if there was a simpler way. And there is. It's called the tabular method. It's where we use a table to help us out. It keeps us organized with all our u's and v's. And the way we do this is we make 3 columns, one for positive and negative, one for the derivative, and one for the integral. So the positive and the negative, you're just always going to start positive, and then it alternates positive, negative, and that's going to be the sign for your derivative. Because when we use the integration by parts, the u times v is positive, and then we minus the integral of the v du. So the first part is positive, the second part we negate. That's where these positive and negatives are coming from, okay? Now the derivative is whatever you find you choose for your u goes here, and you keep taking the derivative until you get to 0. The integral, that's your dv. So the first step is going to be your dv, and you're going to keep taking the antiderivative till you're level with the 0. And then we do products, right? Because we need u times v. We do these products, and we add the results together. So let's try this. So we're going to use the tabular method to integrate. So also remember our liate, okay, our u. Do we have a log? Nope. Do we have inverse trig? No, we don't. Do we have algebraic? Yes, we do. X cubed, that's going to be our derivative or our u part. Now, what's the derivative of x cubed? That's 3x squared. What's the derivative of 3x squared? That's 6x. What's the derivative of 6x? That's 6. And what's the derivative of 6? That's 0. This piece is not going to be used, but that tells us to stop. Also, don't forget, we have to have a positive, a negative, a positive, a negative, and you really don't need the positive here because we're not going to be using the 0 anyway. Then we look at our integral. What's left is we have the e to the 2x, and we're not going to put our dx in this column. Yes, I know it has a dx on it, but we're only going to put the e to the 2x in there, okay? You can put the dx over here if you like. Now, the antiderivative e to the 2x is e to the 2x divided by the derivative of the exponent. So we're going to divide by 2 or make that 1/2. If we take the antiderivative of that again, we still get 1/2 times e to the 2x, but we have to divide by that 2 again, so now we have 1/4. We're going to take the antiderivative again. It's e to the 2x. We have to divide by 2, so 1/4 times 1/2, that's 1/8. We need to find the antiderivative again. The antiderivative e to the 2x is e to the 2x divided by 2, so we take that 1/8 times 1/2, and that's 1/16. So what we're going to do, we're going to multiply. I have a positive x cubed times a 1/2 e to the 2x. And then on the next diagonal, I've got a negative 3x squared times a 1/4 e to the 2x. And then the next diagonal, I've got a positive 6x times 1/8 e to the 2x. And the last diagonal, I've got minus 6 times 1/16 e to the 2x. Now we're just going to do a little bit of arithmetic here to neaten this up. So in the first term, we're just going to have 1/2 x cubed e to the 2x. Then we're going to minus, when we multiply this, we're going to have 3/4 x squared e to the 2x. And then when we multiply this one, 6 times 1/8, that's going to give us 3/4 again, and we're plus 3/4 x e to the 2x. And then 6 times 16, 6 over 16, don't forget my minus, is going to reduce to 3/8 e to the 2x. Oh, and plus c. I almost forgot that down there. And this, my darlings, is our answer. Whoa, right? That's a lot easier organizing it in the table than having to pick a u and a dv 1, 2, 3, 4 times, right? So this is a little easier when we're going to have to do it more than once. Let's try one more together. Or if you want to pause the video, try it yourself and then come back and see. That's also okay, guys. All right, so first thing we're going to do, we're going to try to find our u. Okay, do we have a log? No. Do we have an inverse trig? No. Do we have an algebraic? Yes, we've got x squared. So we have x squared. We're going to take the derivative to get 2x. The derivative of 2x is 2, and the derivative of 2 is 0. So that'll make me done. We need a positive, a negative, a positive. Now, if it wasn't a 0, we'd have a negative, but we don't need that. Next, we're going to find our dv, which is the piece that's left. So we have the sine of 4x. Now, the antiderivative of sine is a negative cosine of the same angle, but we have to divide by the derivative of 4x, which is 1/4. Okay? Now, the antiderivative of the cosine is sine of the same angle, but we have to divide by that same derivative 1/4. So negative 1/4 times 1/4, that's negative 1 over 16. One more time. The antiderivative of a negative sine is a positive cosine of 4x. The derivative of 4x is 1/4 times the 1 over 16 is 1 over 64. All right, now we're ready to put it together. So here we go. On the first diagonal, we're going to have a positive x squared times a negative 1/4 cosine of 4x. And if we put that together, that's going to give me a negative 1/4. There's not much I can do with that. X squared times the cosine of 4x. Now, on the next diagonal, we're going to have minus 2x times a negative 1 over 16 sine of 4x. Now, when we multiply that, the negative times the negative is going to be positive, and the 2 times 1/16 is 1/8. We still have our x. We still have our sine of 4x. On the next and final diagonal, we have a positive term. We have in the derivative column a 2, and in the integral column we have 1 over 64 cosine of 4x, and this time I'm not going to forget my plus c at the end. But when I multiply 2 times 1 over 64, that's going to be plus 1 over 32. Keep the cosine of 4x, and don't forget our plus c. And this, my darlings, is our answer. Okay, there we go. And this is how we can handle having to do multiple versions of the UV integration by parts. Okay, have a great day, guys. Bye.